Hi guys, in this video we are going to be learning what a complex conjugate is, and then we're going to be dividing numbers with complex parts, imaginary parts or complex numbers. So first of all, what is a conjugate or a complex conjugate? So every complex number has this partner that is called a conjugate, okay? So you may not really understand why this is true yet, but eventually you will learn why that is true. It has to do with the solutions that you get from equations, like with square roots in them, because that's where the imaginary number comes from, right? So when you're solving an equation with a square root, we have a positive and a negative of every solution because like 2 times 2 is 4, but also negative 2 times negative 2 is 4. And for that reason, if I have x squared equals 4, for example, then x could either be positive 2 or it could be negative 2. But if it's an imaginary number, then it would be, so for example, 3i or negative 3i. So that's why they have a conjugate. They're called conjugate pairs, is because of that, I guess, what happens when you take the square root of an x squared, for example. So every complex number has one of these, and the only difference between the two is that the part in front of the imaginary part is the opposite sign. So if I have 3i as one solution to something, I know that there's also going to be another solution called negative 3i, and that's called the complex conjugate. Not called negative 3i, that is negative 3i, and that's called the complex conjugate, okay? So let's do just a couple more examples here. If I have negative 4i, then I know the conjugate would just be positive 4i. If I have 2 minus 4i, then I know that the complex conjugate is going to be 2 plus 4i. If I have negative 3 plus I, then I know the complex conjugate is going to be negative 3 minus I. So notice there that the negative that was in front of 3 did not change. Only the one in front of the imaginary part will change to the opposite sign, okay? So every imaginary number has a complex conjugate. It's just the same thing, except for there is a sign change in front of the imaginary part, okay? So now let's go ahead and look at our example over here. So we want to simplify this. We want it in standard form. In order to put this in standard form, we need to have I out of the denominator. We cannot have an I in the denominator and have this be in simplified standard form. So what we want to do here is we want to take the conjugate of this number. So first of all, I can think of this, since it has a negative out front, I can either think of it as negative 4 over 8i, or I can think of it as 4 over negative 8i. So there's basically 3 ways you could write a negative on a fraction. You can put it out front, you can put it on top, or you can put it on the bottom. So the reason that I'm pointing out the difference here is because if you decide you're going to put the negative on the top with 4, and your number is 8i in the denominator, then my complex conjugate is going to be negative 8i. If I decide I want to write it as 4 over negative 8i, then my complex conjugate is going to be positive 8i. And honestly, it does not matter at all which one you choose. As long as you're careful with your signs throughout, you'll get the same answer either way. So I'm going to go with this here, 4 over negative 8i. So I'm going to take the complex conjugate of this, which is positive 8i, and I'm going to multiply both the top and the bottom by that conjugate. If I do this, it's going to give me an I squared in the denominator, and we know that anytime we get an I squared in the denominator, that changes to a negative 1, so that will take the I away, and there will no longer be an I in the denominator, and that's our goal here, is to get it out, okay? So 4 times 8 is 32i. I guess 4 times 8i is 32i. Negative 8 times positive 8 gives me negative 64, and I times I is I squared. But remember, I squared is equal to negative 1, so this would just be 32i over negative 64, no, positive 64, because we have negative times negative. And then 32 over 64, that simplifies to 1/2, right? So I can write this in 3 different no, two different ways. I could write it as 1/2 times I with I out to the side, or I can write it as 1 times I over 2. Both of these are equivalent, and it doesn't matter which one you do. Since we're going for standard form, I guess technically you put the real part in front of I. Well, I guess like the real part of the imaginary part. So usually an imaginary number is a plus bi. So in this one, our a would be 0, and then we would have 1/2 times I. So either one of these would be perfectly fine. Choose one. It doesn't matter. Whichever one's more comfortable to you. Okay? So let's go ahead and try another example. So I have, let's keep going. I have 6 over 9i. So again, I just want to figure out what is the conjugate of the bottom, and then I'm going to multiply this top and bottom by that complex conjugate. So if my number is 9i, the conjugate is negative 9i. So let's go ahead and multiply these. 6 times 9, that is 54. And it's going to be negative 54 times I. 9i times negative 9i, that's negative 81i squared. But then remember that I squared is equal to negative 1. So on the bottom here, I have negative 81 times negative 1, which is equal to 81. And then on top, I have negative 54i. So now what I want to do is I want to reduce these if they have a common factor, which they do here. The common factor here would be 27, because 27 times 2 is negative 54. So this would be negative 2i over 3. 27 times 3 is 81. So again, I could write this as negative 2 times I on the top and 3 on the bottom, or I can write it as negative 2/3 I with I out to the side. Doesn't matter which one, as long as I is not in the denominator, they're both the same, they're both equivalent, and just circle one, okay? All right, so let's look at something slightly different here. Well, let's do this one. This is not what I was thinking, but we'll do this. So I have a negative 1 plus 8i over negative 2i. Remember, this is the one down here that we want to get rid of. So we're going to find the conjugate, and it's going to be 2i. And then we're going to multiply top and bottom by 2i. But because the top has more than one term, I'm going to put parentheses around that. That 2i is going to need to be multiplied by each one of those here. So 2i times negative 1 is negative 2i. 2i times 8i would be 16i squared. And on the bottom, negative 2i times 2i is negative 4i squared. Now remember, I can replace that I squared with a negative 1. Negative 4 times negative 1 is 4. Up here, this can also be replaced by negative 1. So this would be negative 2i minus 16. So really, I could write this as, I'm going to change the order a little bit, because remember, if you're writing a complex number, the standard form is to have the real part first and the imaginary part second. Since these are both over, or since the common denominator here is 4, I can actually divide this into two questions. Negative 16 over 4 minus 2i over 4. And then because 16 and 4 goes evenly into 16, I can write that as negative 4. And then 2 over 4 reduces to 1/2. So I could write it as negative 4 minus 1/2 I, or negative 4 minus I over 2. Either one of those they're both the same, they're equivalent, so just choose one of them and circle it. Okay, let's try one where we have a binomial in the bottom instead of a monomial. So we have to skip ahead a little bit here. So here we go. So we have 2 minus 2i as our complex number in the denominator. So the conjugate of that is going to be 2 plus 2i. So I need to multiply this fraction, top and bottom, by that conjugate, 2 plus 2i. So remember, we're just doing this so that we can get I out of the denominator. It's really just a very fancy way of writing, timesing this expression by 1. So we're not changing the expression, we're just, it's called rationalizing the denominator. Get that denominator to not have the I in the denominator. So go ahead and put parentheses around your original two terms, because again, if I'm multiplying this whole top by 2 plus 2i, I've got to multiply the whole thing by it, and I've got to group it properly. So here I'm going to use the distributive property. I'm going to multiply negative 6 times 2 to get negative 12. And then negative 6 times 2i would be minus 12i. Then I do the same thing with 8i. 8i times 2 would be plus 16i. And then 8i times 2i is 16i squared. So we'll simplify that in a second. Now we're going to go down here. 2 times 2 is 4. 2 times 2i is 4i. Negative 2 times 2 is negative 4i. And negative 2i times positive 2i is negative 4i squared. So now I'm going to ignore like the bottom while I simplify the top, and then vice versa. So remember, I squared equals negative 1, so I can replace that I squared with negative 1. So this would become a minus 16. So I have negative 12 minus 16, which is negative 38. And then negative 12i plus 16i would be a positive 4i. So that's the numerator. On the denominator, negative 4i squared is going to become a positive 4. And 4i minus 4i cancels out. Now, the i's in the middle should cancel out every time if you multiply your complex number by its conjugate. Every time you do that, those middle two terms should cross out. So just make sure when you're doing that they do, or you've probably made a mistake somewhere. So my denominator is now just 4 plus 4, which is 8. So now, because I have that common denominator of 8, I can rewrite this as negative 38 over 8 plus 4i over 8, or 4/8 times I. Now 38 over 8, those have a common factor of 2, so I'm going to reduce or divide them both by 2. So this would give me 19 over 4, and 4 over 8 again reduces to 1/2. So I could write it as negative 19/4 plus 1/2 I, or I could just put that I on the top here. Either one will be fine, but now it's in standard form because we have our real part plus our imaginary part. Okay. So let's just go ahead and do one more example. So here I have 2i over 4 plus 7i. So I'm going to go ahead and I'm going to multiply top and bottom by the complex conjugate. Remember, the sign in the middle in front of I is the only one that will change. The one out front stays the same. So first of all, I'm going to multiply 2i into the parentheses. I'm going to distribute that. So 2i times 4 is 8i. And then 2i times negative 7i is negative 14i squared. On the bottom, I have to put parentheses here, and I need to distribute both of these. So 4 times 4 is 16. 4 times negative 7i is negative 28i. 7i times 4 is plus 28i. And 7i times negative 7i is negative 49i squared. Since those middle two terms will cancel out each time when you do that, you can kind of do a shortcut and just do 4 times 4 is your first number, and 7i times negative 7i is your last number. But it's, I guess, if you're going to do that, just don't get in the habit of forgetting that you're supposed to actually distribute to each term. It's just that those middle terms are canceling out. Now, each I squared can be replaced by negative 1. So this would become 8i plus 14 on the top. Oops, got my I. And on the bottom, I would have 16 plus 49. So 16 plus 49 is 65. Yes. And then 14 plus 8, I would want to change the order so I have the real part first and then the imaginary part. And now I can break it up. It's 14 over 65 plus 8i over 65. So check for common factors again to see if you can reduce your fractions. I don't believe we can on this one. So go ahead and give some of these a try, and we will see you next time.